talk about something different. Let's talk about something called scientific notation. Scientific notation is used to write out very large and very small numbers. And what do I mean by very large and very small numbers? For example, a very large number might look like something like 14 million. A very small number might look like something 0.00000025. And these could be positive or negative. What scientific notation lets us do is rewrite these. So, something like 14 million would start off by turning into a decimal number that would be between 1 to 10. And then you'd have some kind of exponent of a power of 10 that you'd be multiplying by with some exponent up there. Same thing with the decimal version. We would turn it into some number between 1 to 10 as a decimal. And then times 10 with, it would have a exponent on it. Well, let's see what the exponent does. The exponent tells us how big or how small the number is. So this exponent here is going to tell us how big or how small the number is, depending on the number and whether or not it's positive or negative. What's going to go in our other place value here at the beginning is going to be our regular number. Just if I were to look at it as a number between 1 to 10. If I wanted to convert this in between a number from 1 to 10, I'd just look at the 1 and the 4. And I would want to force the decimal somewhere in between the 1 and the 4. That's what would start off my scientific notation. Same thing with my other example, as I would want to look at the 25 at the end, but I'd want to turn it into a number between 1 to 10. And the only way to do that would be to force the decimal between the 2 and the 5. And again, that would start out my scientific notation. The question is, how do I force my decimal into these places? Well, I have to move it. That is what the exponent does. And the exponent will either move your decimal left or it will move it right, depending on if it's positive or if it's negative. The actual value of the exponent will tell you how many places you're actually going to move it, either to the left or to the right. So let's take an example and kind of try this out and see how it goes. So we've got this first number, 93 million. To turn it into scientific notation means I want to turn it into a number between 1 to 10 first. Well, then the only number I can turn it into, at least to start with, is if I put the decimal, if I focus at the beginning of the number, between the 9 and the 3. That will make a number between 1 to 10. So that will put at 9.3. Okay, so I want the decimal between the 9 and the 3. However, that's not where the decimals start. Decimals always start at the end of a number if you don't see one. So the question is, how many places do I need to move it to make it look like the 9.3? Well, that's the second part that comes into your scientific notation that has that times 10 to the, well, that's how many places we actually have to move our decimal. Well, I have to go from where it was at the beginning, 1, 2, 3, 4, 5, 6, 7 places. So that means my exponent here on my 10 is going to be a 7. Your question should be, is that a positive 7 or a negative 7? Well, let's make this really easy. What kind of number is this? Is it a really big number or is it a really small number? Well, it's a really big number, and big numbers are going to have positive exponents. So we're going to leave that as a positive 7. So this 9.3 times 10 to the positive 7 is our final answer for our number in scientific notation. That's what we would be inputting. Let's try another one. On this next one, we have 0.00125. Okay, again, let's look at the numerical part like we did on the last one first. the 125. Well, if I want to turn this into a number between 1 to 10, the only place I can put the decimal is between the 1 and the 2. If I actually put it in between the 2 and the 5, I'd actually get 12.5. And remember, I don't want to be any bigger than 10, so I need to stick it between the 1 and the 2. Well, notice the decimal was originally way up here. So how many places did I have to move it? 1, 2, 3 places. So what that means is my exponent on my times 10 to the, for my scientific notation, is going to be some version of 3 because I had to move it 3 places. The question is it going to be a positive 3 or a negative 3? Well, again, let's make this easy. What kind of number is this? This is a small decimal. So, if this is a small decimal, it needs to be a negative exponent. So it'll be a negative 3. So my final answer for this number turned into scientific notation is a 1.25 times 10 to the negative 3. And that's my final answer. Here's another one. On this next one, we've got 17,500. So we would start off by making sure that we convert this into a decimal between 1 to 10. So we'd start by looking at the numerical part, the 175. And the only place to put the decimal, if you want this number to be between 1 to 10, is between the 1 and the 7. So that would start us out with 1.75. The question is, to write it as scientific notation, is how many places did we move our decimal place? That will tell us what the exponent is going to be up here on our 10. Well, originally the decimal comes in at the end of a number. So we'll start out with it at the end of the number and ask how many places did we have to move it? Well, we had to move it 1, 2, 3, 4 places. So that tells me my exponent will be a 4. The question is, will it be a positive 4 or a negative 4? Well, my original number, was it a big number or a small number? Well, it's a big number, so it's going to have a positive exponent. So we're going to leave it as is, the 1.75 times 10 to the positive 4th exponent. Okay. Here's another one, D, 0.657. To turn this into a decimal between 1 to 10, let's see, we look at just the numerical part. That means we would want the decimal between the 6 and the 5. So it'd be 6.57 times 10 to the, well, how many places did you have to move the decimal? It's 1 place. The question is whether or not it's a negative or a positive 1. Well, remember, this is a small number, so it should be that you're using negative exponents because it's a small decimal, so that should be a negative 1. So our final answer for our scientific notation is 6.57 times 10 to the negative 1st power, and there's our final answer for D. Last one, we've got a negative 976,000. And let's see, just looking at the numerical part, ignore the negative. If you didn't have a negative and you just had the 976,000, where would you want your decimal? Well, you'd want it between the 9 and the 7 because it needs to be a number between 1 to 10. So what that does is then it gives us 9.76 times 10 to the, well, how many places did you have to move the decimal? Well, normally it starts at the end of a number, so we'd have to move it 1, 2, 3, 4, 5 places, and ignore the negative. What kind of number is this? It's a big number, not a small decimal, which means that the exponent needs to be positive. And then what we'll do is we'll do something kind of sneaky. We'll just put the negative out in front at the end. So our answer here for our scientific notation is negative 9.76 times 10 to the 5th. So when we're talking about whether our numbers are big or small, we're not talking about positive or negative. We're talking about whether or not they're just really big numbers with lots of zeros, or if they're really small as in tiny, tiny decimals.